Chapter 6, Segment 3, Stereoscopes and Stereograms. Depth you can see depends on whether you converged or diverged your eyes. Divergence requires focusing on a point beyond the plane of the page so that the image of the left-hand set of squares falls on the left fovea and the image of the right-hand set falls on the right fovea. If you converge, the top square will be the furthest back. If you diverged, it will appear the closest to you. This creates a clear stereoscopic effect. So stereo blindness is just lacking depth perception. Random dot stereograms. Someone named Bella Jules theorized that stereopsis might be used to discover objects and surfaces in the real world. Random dot stereograms are made of a large number of randomly placed dots and contain no monocular cues to depth. So cyclopean refers to stimuli that are defined by binocular disparity alone. So stereo movies, TV, and video games. 3D movies, TV, and video games are the new stereoscope. Earliest 3D movies were viewed with the anaglyphic glasses with a red lens for one eye and a blue or green filter for the other eye. So one eye saw one set of images and the other eye saw the other set. Modern 3D movies, TV, and video games use glasses that contain liquid crystal display technology and enables the presentation of images to each eye that are synchronized with the images on the movie, TV, or computer screen. So alternate frames of the movie are presented to different eyes. A way to get 3D movies without glasses is called lenticular printing, and that's when images are digitally split and interleaved at a fixed spacing. So using binocular stereopsis, can provide useful information about metric depth only for distances up to about 40 meters. You can use stereopsis to have a better look inside the body, so x-rays of breast tissue to detect breast cancer. So is binocular stereopsis useful in everyday life? Visually guided hand movements are significantly impaired when viewing is restricted to one eye, owing to the fact that binocular depth thresholds are about a factor of 10 better than monocular thresholds. Loss of stereopsis may also result in unstable gait, especially reduced accuracy when a change of terrain occurs. Stereoscopic correspondence. So the correspondence problem is the problem of figuring out which bit of the image in the left eye should be matched with the bit in the right eye, particularly vexing when the image consists of thousands of similar features. Before random dot stereograms, similar logic seemed reasonable for simple and complex scenes. Our visual system could solve the correspondence problem by first finding the parts of two faces that then matching nose to nose, mouth to mouth, and so on. So the uniqueness constraint is the observation that a feature in the world is represented exactly once in each retinal image. This simplifies this correspondence problem, but does not fix it. Visual systems also knows that each monocular image feature should be paired with exactly one feature in the other monocular image. So the continuity constraint is except at the edge of objects, neighboring parts in the world lie at a similar distance from the viewer. Disparity should change smoothly at most places in the image. So physiological basis of stereopsis and depth perception is input from two eyes must converge onto the same cell, but this does not happen until primary visual cortex. A binocular neuron has two receptive fields, one in each eye. Many binocular neurons respond best when the retinal image are on corresponding points in the two retinas. Other binocular neurons respond best when the similar images occupy slightly different positions on the retinas, tuned to a particular binocular disparity. So stereopsis can be used both metrically and non-metrically. Non-metrical stereopsis might tell you that a fixture lies in front or behind the plane of fixation. And this found that disparity-tuned neurons of this sort in visual field 2. But they can also be used in a very precise symmetrical matter. So stereopsis is a type of hyperacuity and has threshold higher than the size of a cone.